Yeah, so I'm gonna talk about how we use Puppet here at Spotify. Because we're fairly big users of Puppet. So you probably all know what Spotify is and so on. So I'm not gonna explain that, but just to give you some sort of idea of like the scale we're operating at. So we have like over 20 million active users at the moment. We're launched in 17 different countries. We have over 20 million songs and more than 1 billion playlists in our system. So there's tons of other metrics, but they're all growing fairly quickly, all of these metrics. So it's also, poses a lot of challenges and interesting challenges. And to manage all this, we have a SRE team of 15 people, or around 15 people at the moment. And a lot of developers that are also helping out quite a bit. Otherwise, we'd probably have to be a lot more sysadmins to manage all this. But Puppet is one of the main tools we use for like allowing developers to help us with the administration of stuff. So to talk a bit about our Puppet infrastructure, we're managing roughly 3,500 nodes at the moment using Puppet. And that's, that's both servers but also actually laptops and desktops. So it's mixed like Linux servers and Windows and Mac OS like laptops. So there's like 3 different Puppet installations. One for the testing environment, one for all the laptops and desktops, IT, Puppet Master, and then there's an installation for the production environment. And that's actually 3 different Puppet Masters, but they're sharing the same certificate authority and the same PuppetDB installation. So I have 3 different certificate authorities and 3 different PuppetDBs as well. And it's all running on Puppet 3. Upgraded in testing, we've upgraded to 3.1. I haven't found any bugs so far, at least, so it seems all good. And as I said, in the production, that's 3 Puppet Master, which is 1 per data center, so I have 3 different data centers. Puppet is a fairly chatty protocol, so having the Puppet Master close to your nodes will speed up the runs quite a bit. So we've been using Puppet for 2.5 years. We started out in a smaller scale with that, so we haven't been managing everything with Puppet for 2.5 years, but we started managing some stuff 2.5 years ago, and then we've grown that since then. And by now we're managing pretty much everything using Puppet. And one thing that might be a little bit different compared to how a lot of people are using Puppet is that we don't have any like scheduled downtimes where we like any weekly downtimes or stuff like that. So we just, when things get merged into our Puppet codebase, it immediately gets pushed out to all the agents. Or they're running every half an hour. So within half an hour, they have the new code. And we do more than 300 changes to our Puppet code base, or on average, around 300 changes to our Puppet code base per month. So that's quite a lot of changes all the time. And there's actually 137 people that have committed code into the Puppet code base as well. So we allow developers to write Puppet code, or we encourage them to write Puppet code, and then that is sent to Gerrit that we use as a review system, and that can then be like approved by the sysadmins and merged into the production branch, and then it's out on the servers. And we have around 240 different Puppet modules. So that's quite a lot. We have Puppet modules for pretty much every backend service that we have, and then I mean, a whole bunch of like components that are, I mean, for databases and that sort of stuff that are shared between services. And I mean, to be able to scale this to this many people and so on, we map Git branches to Puppet environments, which I think is a very good technique to do it. So, I mean, developers can develop in like feature branches, Puppet code, and push it up to Gerrit without any reviewing going on, and then they can run Puppet against a different Puppet environment that is mapped into a Git branch. So I have a small like wrapper script around Puppet. So you can say like, I want to run Puppet but on this Git branch, and then it will do a run against that, and you can test your code. I mean, you can run with no op if you want to. You can run and actually implement those changes and see that everything works out. So, I mean, the reviewing system is doing some like basic checking. We're using Puppet lint and also the Puppet syntax checking of all the code to just see that it's like following the style guidelines and that it actually compiles. But we try to have people actually test the code on, preferably in the testing environment, before they send it for review. But it's possible to test it in the production environment using the same technique. If you prefer to do that. And I mean, for backend services and so on, we're building them as Debian packages. We're a Debian shop, and so that's what we're running on all the servers. So, I mean, there's a fairly big like baseline in Puppets that we just deploy to every server because there's not that much difference between them as they're all running Debian and so on. But so for every backend service, we build a Debian package, and then we use Puppet to deploy those packages, just using the normal package resource provider. So nothing special, but I think that's a good method to do it. So I mean, when developers build like new backend services and they want to deploy them in testing, they're built as Debian packages, and they write the Puppet module for it, test that out on some virtual machines in the testing environment, and then later on we can like merge that into the production branch and deploy those in production using the same Puppet modules. So, in regards to node classification, at the moment we're in a little bit of a messy situation there, where we're using different node classifiers in every Puppet installation, which is, a little bit of a mess, to be honest. But we're planning on moving that, or are in the process of moving that to using Hira to classify nodes. So that would basically be like defining those roles in Hira, then, pretty much. And to do that, we've decided on a new hostname standard. So up until quite recently, we were actually using like email names on all the servers. Up until we had like close to 2,000 servers. And yeah, if you're using that naming scheme, you should probably stop before you're at that scale and switch to something easier. But yeah, we switched fairly recently. So there's still a lot of nodes that have like email names. But now all the servers, or all the new ones at least, are having a hostname that is based on like the site or their location, and then the name of the service, which would be basically the role they have. So that's also like they can only have one service per node, and kind of like the role. And then it's in what pool they belong in, and the ID in that pool. So you can have like, in some special cases, you can have like different pools of the same service. And it's mainly then the service fact that we will be using to specify what Puppet classes should be on each machine. So we just use Hira for that. And this is our current Hira hierarchy. So there's quite a few levels in that one. And yeah, we should probably try to keep it to a minimum. Some of those are to allow for like avoiding having like kind of wrapper classes that just sends, like includes other classes with the specific parameters or that sort of stuff. But mainly like the service level is what is going to be used. And we also have like a directory for each hierarchy level, so we don't just have all the YAML files in one single directory, as that can be a little bit messy. I mean, sure, the host names look different from the service names and so on, but it's still kind of messy with that many different. And they're in the same Git repository. So when you're like using Git branches and so on, you can, only change the Hira data and add another branch and run Puppet against that and just test it with your new Hira data. And that also allows us to use like Git blame and history and reviewing in Gerrit and all those nice features, but that we can use also on the data. But we also have like a small web service, so you can, if it gets a little bit complicated to see like, well, what data will this node get, then you can query that to see like, oh, this is the data the node would get. And that's like the whole node classification. And then we have the service discovery part of it. So at the moment, at least, we're using Puppet to like configure a node as a specific service. But that doesn't entirely mean that it's in production as that service. And at the moment, we're using SRV records to discover services. So all the backend servers, services, they're using SRV records to discover the other backend services that they need to talk to. We're planning to also use SRV records for Puppet, but there were some bugs in that, but they're fixed in 3.1. So as soon as we deploy that into all the installations, we can use SRV records for Puppet as well. And yes, we heard earlier, we have like this DNS query module as well, so you can actually like query the SRV records and that sort of stuff inside Puppet manifests. If you need to, sometimes you might want to embed them in like the actual IP addresses or host names in template files, but if the application doesn't support looking it up at runtime or that sort of stuff. So it's only used in a few special cases, but it's possible if you need to. Yeah, so then for service discovery, as a kind of wrapper tool around that, we have a tool called WASD. What are servers doing? Abbreviation. It's on GitHub. It's using, it ingests all these SRV records into a Cassandra database. We're fairly big users of Cassandra. And it can also query Cassandra about its kind of knowledge about the other nodes in the Cassandra cluster. And then you can ask the service, like, what is this? Is this node in production? Like, is it serving, or which nodes are serving traffic for this site? And like, or which servers of this service are we having in this site? So, servers in one site can actually be serving that service for servers in another site and that sort of stuff. We try to have most services in all of the sites, but some of them are only in some of the sites. And it also has a REST API So you can easily query that, but you can check it out on GitHub. That's not, I mean, it's not a like Puppet tool, but just as a kind of side note to the whole node classification thing, and like, yeah, the difference between the node classification and the service discovery part. So that's about it. But do you have any questions? Yeah, I don't know, a mic or I don't know.
I was just wondering about you said you had about 3,500 nodes. Do you use any load balancing?
No, at the moment we don't use any load balancing. So, I mean, it's basically so they use their local Puppet master. So there is some sort of balancing there where, I mean, it's only the nodes in that data center that will use that Puppet master. With the SRV records, we could probably do some fairly easy load balancing using them, which is slightly easier than putting a load balancer in front, but we're not doing that at the moment. I mean, so far they're handling the loads. They're fairly beefy machines, like 24 core with 48 gigs of RAM. But at least the heaviest loaded Puppet master is actually managing around or compiling around 1,000 resources per second. So, I mean, there's like one Puppet run every 2 seconds around, and then each catalog contains around 2,000 resources. So, yeah, that's about the rate that they're handling at the moment, and it has a bit of load, but we could probably put a lot more load on it. Yeah, I think there was
more questions over there. I'm running.
So you seem to have quite a few like truth sources for what your nodes are doing. Like, how do you manage drift between the different truth sources? Like, if you decommission a server, if you ever do that, like, do you have some sort of central coordination to manage all of your truth sources to remove it, or like?
Yeah, we have a like inventory system basically that is our own. It's called ServerDB, and yeah, at the moment we don't yet have a like tight coupling between that and the PuppetDB. So at the moment it just like we use the expiry functionality in PuppetDB. So if they haven't been running Puppet for a while, I mean, they'll get deactivated. But otherwise, when we decommission a node or set it to decommission in ServerDB, we can also like tell PuppetDB to deactivate it.
Okay. And my second question would be, like you say that you're running Puppet schedule, you have scheduled Puppet runs on all the servers, right? So when you deploy a new version of your software, do you just push it out and then the nodes will upgrade, you know, as they happen to be on their interval, or will you like do a push that so that all the servers for a particular application run at the same time?
It's a little bit different for different backend services at the moment. So usually we don't want every server to upgrade within half an hour because,
yeah.
I mean, it also depends a little bit on the application. I mean, some of the backend services, like the storage servers, for example, that are actually like, I mean, serving the songs and music content. I mean, they have fairly large caches and so on, so they actually need a kind of time to warm up after restarting them, which is several hours before they fill their entire cache. So there it would be like a very bad idea to upgrade all of them within half an hour. So, I mean, then we can, in some cases, we just have a kind of ensure installed in Puppet, and then you can go out and do a like apt-get dist upgrade on the nodes, and like do that, like kind of rolling on them. In some cases, we specify the package version in Puppet, so then you could like do that in a separate Git branch, and then you change the Puppet environment they're running against. So you change them to run against this like new version Git branch, and then you do that like kind of rolling across all the nodes. And when you're done with all the nodes, you can merge that change in and then switch them all back to the production branch. So there's a few different methods that we're using at the moment. None of them are probably perfect, but yeah, that's how we do it. But it's also, like, as I said, different for different backend services that have a bit different requirements and so on.
Okay. Thank you very much.
Any more?
Yeah, there's another one over there.
Yeah.
Hi, thanks. I was wondering, if you have services cooperating and they want to join a cluster, how do you handle cluster membership when you deploy?
I'd say, I mean, that's a little bit application specific.
So it's not something you put inside Puppet manifests or modules or Hera?
For Cassandra clusters, we can, like, put our Cassandra Puppet module has a way so you can, like, define the token they should get in the Cassandra ring in Hera, and then they'll use that as the initial token, but then actually Cassandra itself stores that in its, like, data files, and it will use whatever is in the data file from there on, and kind of ignore whatever setting you had in the config file. For a lot of the other, like, our backend services, they're fairly stateless. So I mean, they're just kind of running on a bunch of individual nodes, and then the access points that you're connecting through will, or the other services that are using them, will kind of load balance between them. So they're, like, in a cluster, but it's using the SRV records to just kind of spread the load among them.
Thanks.
Okay, thanks, Erik.
Thanks.